Hello, good afternoon, guys. My name is Steve Oshiokhai Eshiemogie. In this video, we will be looking at CHE 521, that's Chemical Engineering Analysis. So this would be our first tutorial video for this very course, CHE 521. Chemical Engineering Analysis. Chemical Engineering Analysis. Okay, basically this course involves using mathematical methods to provide solutions to chemical engineering problems. The first outline we would look at in this course would be maxima of functions through the use of calculus. Maxima of functions through the use of calculus. So it would be good you brush up your knowledge on calculus, because that is a very important prerequisite for this course. Okay, so let us just go straight to the agenda. I wouldn't want to spend much time talking. I would want us to just solve questions, because you would understand the course better when we handle questions. Okay. When talking about maxima, minimum, and all of that, one great thing that these things apply to is optimization. Optimization. In chemical processes, in fact, any engineering process at all, you may be called to optimize the process. Like, how can you use minimum resources for maximum output? So that's basically optimization. You look for the best model, the best way a process should operate. So that's how you optimize a process, looking for the best way the process should operate. Okay, so that's optimization, basically use of specific methods to determine the most cost effective or the most efficient solution to a problem. Yeah, so let's just move to solving questions. Okay, before that, let me throw more light on what we want to do. Maxima and minima. You can see of functions of two variables. So this is the first thing we would look at in this course. Maxima and minima of functions of two variables. Okay, that's what we'll be looking at. I will just list out rules to follow, so that when we start solving, it will just be easy for us. So I will just list out the rules that we'll follow. So when you have a question asking you to find the maxima and minima of a function, so actually in this course you'd be given a question. Say a function, given a function of x and y, and you'd be asked to find the maxima or the minimum value of the question. Okay, now let me just list out the rules that we are to work with. So the first thing, when given a question like this, to find the optimal values of the question, the first thing that you do is to find, so let me just name rules. The first thing you do is to find f of x of the function xy. What this means is that you differentiate the function with respect to x. Okay, you differentiate the function with respect to x. Then the second thing you do is to differentiate the function with respect to y. I think this is clear enough. So that's the first thing you do. You differentiate with respect to x, then you differentiate with respect to y. The second thing you will do is to solve the equations. So whatever equation you arrive at, because there are two equations now, f of x of the original equation and f of y of the original equation. So the next thing you do is to solve the two equations simultaneously. But before doing that, you say let's make f of x into xy is equal to 0 and f of x into xy also equal to 0. So that's the second thing you will do. Then the two equations, you solve them simultaneously. Okay, then you get two roots. When you do this, you get 2 points, 2 roots, sorry. That's a point. Let's name this point A and B. So that's what you will get. Now this point A and B is called the critical point of the question. So A and B will be called the critical points. Okay. Now we want to know if this critical point is a maximum point or a minimum point. So how you do that, or a saddle point, how you do that, you use step 3. Now you find f of x of x comma y. What this means is that you differentiate this again with respect to x. Okay, then you find f of xy of x and y. What this means is that this one, you differentiate it with respect to y. And lastly, you find f of y, x and y. What this means is that this function of y that you've differentiated before with respect to y, you will differentiate it again with respect to y. Now this one, step 4, you name this A, name this B, and you name this C. So that's your step 4. Now step 5, if AC minus B square is greater than 0 and A is less than 0, that means that this function is maxima at these points A and B. So what you have here is a maximum point. It means that, it implies that AB is maximum. It's a maximum point. Now, if AC minus B square is greater than 0 and A is also greater than 0, then what you have here, these points A comma B, is a minimum point. Now, if AC minus B square is equal to 0, further investigation would be necessary to determine if it's maximum or minimum. So just want further investigation. Okay. If AC minus B square is less than 0, yes, this other point, that means that A comma B is a saddle point. SADDL is a saddle point. Okay, it's a saddle point. Now these rules will seem so abstract. It looks so abstract right now, but when we solve one example, when we start solving examples, then you would get to see that these rules are easy. So example 1, remember here, example 1. Find the extreme values of the function two xy minus 5x squared minus 2y squared plus 4x plus 4y minus 6. Solution. So this is your f of x. F of x and y, sorry. 2xy minus 5x squared minus 2y squared plus 4x plus 4y minus 6. Now from the rules, it says we should find f of x and y. That's we should differentiate function f of x and y with respect to x. So that's the first rule. So f of fx of x and y is equal to If you differentiate all this with respect to x, you get 2y minus 10x. This will become 0 plus 4. That's all. Now fy of x and y, you differentiate this with respect to y, you will get 2x, this is 0, minus 4y plus 4. Okay, now rule 3 says, rule 2 says we should make both of them equal to 0, right? And solve simultaneously. Remember, I didn't write it. Solve simultaneously. Good. So what we have here will be equal to 0. So 2y minus 10x plus 4 is equal to 0. And 2x minus 4y plus 4 is equal to 0. So solve the resulting simultaneous equation. Should I solve it, or okay, let me just solve it for this very first video. So this is the same thing. Let me bring this thing here. So this is minus 10. I can times this by 2, and this would just remain times 1. So this would become minus 20 times 2 is equal to minus 20x. Minus 20x plus 2 times 2, 4y. Let me take this 4 to this other side. It's equal to minus 4. But minus 4 times 2 is minus 8. Then this other case remains the same. 2x minus 4y is equal to minus 4. I hope you understand the mathematics. Now let me subtract, or let me add both sides. Add both of them together. Minus 20x plus 2 is minus 18x. 4 plus minus 4 is 0. This plus this is minus 12. So x becomes minus 12 over minus 18, which is 6 can go into 12 in 2 places, 6 in 18 in 3 places. So x is equal to 2 over 3. Now how do you find y? You just put it into any of the equation here. Since x is 2 over 3, let me put it into this equation 2. Okay. Now equation 2 says 2x. Let me just write it here. Equation 2 says 2x minus 4y is equal to minus 4, where x is 2 over 3. So 2 times 2 over 3 minus 4y is equal to minus 4. Okay, so if y goes here, we'll have 2 times 2, 4 over 3. That's 4 over 3 minus 4 is equal to 4y. So it's very easy, right? 3 times 4 is 12. So 4 minus 12 over 3 is equal to 4y. What's 4 minus 12? Minus 8. Is it minus 8 now? 4 minus 12 is minus 8. So minus 8 over 3 is equal to 4y. If we divide both sides by 4, we're going to have y is equal to minus... Oh, I've made a mistake. Okay, yes, I made a mistake. When I took this minus to the other side, it became plus 4y. Then when this one crossed over, there was to be plus here. The plus here. 4 plus 12. That's 16. So it's 16 over 3. So divide all through by 4. 16 divided by 4. That's y becomes 4 over 3. So just do the math, solve it simultaneously else. So x is this and y is 4 over 3. Okay. I guess this is clear now. Now that we found this from our rules, so these are the 2 points. Good. So our critical points are critical points xy are 2 over 3, 4 over 3. Okay, so these are our critical points. Now, how do we know if these points are maximum or minimum points? So that's what we just want to look at. So that's what these other parts would help us find. Now the next rule says find fx of x and y, name it a, xy of x and y b, and all of that. So let's do it. So this is the question. Should I need to be seeing what we're doing. So let's proceed on this page. Good. So the function f x of x and y is 2y minus 10x plus 4. Now to find fxx of x and y simply means we're going to differentiate this line with respect to x. So we'll have this turns to 0, this turns to minus 10. That's the answer. Then fxy of x comma y, we're going to differentiate this same function now with respect to y, and we'll be left with 2. Now fyy of x and y, if you differentiate this one with respect to y, you'll be left with minus 4. I remember that the rule says this one should be a, this one should be b, and this one should be c. So that's how we're going to name it: a, b, c. Now let's find ac minus b square and c. AC minus b square would now be minus 10 minus 4 minus b is 2 square. So this becomes 40 minus 4. So this becomes 36. Now that means that this 36, is it greater or less than 0? It's greater than 0. So AC minus b square is greater than 0. But what is A? A is minus 10. A is less than 0. So you go back to the rules. AC minus b square is greater than 0 and A is less than 0. So that point is a maximum point. So our critical point, therefore our critical point (2 over 3). I think those are our critical points. 2 over 3, comma 4 over 3 is a maximum point. It's a maximum point. So you see how easy it is, right? Then to find the value, the maximum value, so this is the maximum point, but to find the maximum value, you just put this into the original equation, which is this one. So the maximum value becomes 2, what is x? 2 over 3. What is y? 4 over 3 minus 5 into 2 over 3 square minus 2 into 4 over 3 square plus 4 into 2 over 3 plus 4 into 4 over 3 minus 6. So you do everything with your calculator, your head, anything, anyhow you want to do it, you do it and you get your maximum value. So that is how it works. That's how it works. Now let's move to the next. So find the maximum value, okay? I don't have my calculator here. So let's move to the next question. Question 2. Let me solve it in my book. Question 2 says find the extreme values of the function x cubed y square into 1 minus x minus y. Solution. So the first thing you do, like I said, this is f of x and y is x cubed y square to 1 minus x minus y. So we want to differentiate. Before differentiating now, because now I want to find fx of x and y. Before differentiating, let's just expand this bracket. So this becomes x cubed y square minus x 4 y square minus x cubed y cubed. Okay, so now we can now find fx of x and y. Let's differentiate this with respect to x. This becomes 3x square y square minus 4x cubed y square minus 3x square y cubed. Now fy of x and y becomes, you differentiate this now with respect to y, it becomes 2x cubed y minus 4 minus 2x raised to the power of 4 y minus 3x to the power of 3 y squared. This is basic calculus, basic differentiation. So you have to make sure you understand differentiation very well. So that's what we have. So the next rule says we should equate this to 0 and this other one to 0 and to solve simultaneously. Okay. Now, how do we solve this equation? May look complex. So let me bring out the common terms. So x square. Okay, x square is common. So let's have x square. Y square is common also. X square y square. That will be 3 minus 4x minus, is this y minus 3y is equal to 0. For the second equation, what? Okay, x cube is common. So x cube, y is common. Y becomes 2 minus 2x x cube, so x is left, y is out, minus 3y is equal to 0. Now, looking at this equation 1 and 2, you can see that x is multiplying y is multiplying this and it's equal to 0. Same here. It means that either x is equal to 0, y is equal to 0. So these are points. Whenever x is equal to 0, either x is equal to 0 or y is equal to 0, and or what you have here is equal to 0. I don't know if you understand what I'm saying. Let me cancel this. Either x is equal to 0 or y is equal to 0, because x, something must be equal to 0 here. So either this or whatever you have here, or something, this whatever you have here should be equal to 0. Same thing applies for this one. Either this equal to 0, this equal to 0, or this is equal to 0. So now that we established these two, let's now find the other one. Solving these two simultaneously. 3 minus 4x minus 3y is equal to 0. And 2 minus 2x minus 3y is equal to 0. So let's subtract equation 2 from equation 1. So 3 minus 2 is 1. Minus 4 minus 2 is minus 2x. Minus 3 minus minus is minus 3 minus is 0. So we have that x is equal to 1 over 2. So you can put it back into any of the equation to get y. Okay, when you do that, you will find out, let's just do it. X is equal to 1 over 2. Put it into this equation. Put in equation 2. That's 2 minus, hope you can see what I'm doing. 2 minus 2 into 1 over 2 minus 3y is equal to 0. That's 2 minus 1. That's equal to 3 comes here. 1 is equal to 3y. So y becomes 1 over 3. So these are our points. Either x is equal to 0 or y equals 0, or x is equal to 1 over 2 and y is equal to 1 over 2. So whenever x is equal to 0, y is equal to 0. That's for that point. Then when x is equal to 1 over 2, y will be equal to this. So our 2 points could either be 0, 0 or 1 over 2, 1 over 2. Okay, so these are our two critical points. And these are our 2 critical points. So now let's find A, B, and C. So to find A, B, and C, like we did in the previous example, f of x, fxx of x and y is equal to 6xy squared minus 12x squared y squared minus 6x y cubed. F x y of x and y is equal to 6x squared y minus 8x cubed y minus 9x squared y squared. Okay, now f of y and y, I hope you understand what I'm doing. I've explained all of this before. F of y and y would be the differentiate this one with respect to y again. 2x cubed minus 2x is equal to 4 minus 3x cubed y squared. Okay, now for the points 0, 0, so you put in all these values inside. 0, 0, a becomes 0, b becomes 0. If you put, whenever I see x, put 0. If I see y, substitute 0. C will equal to 0. So ac minus b squared, if you do it, 0 minus 0, 0 times 0 minus 0 squared, it's all 0. And you remember from our rules, it states that whenever this equation gives you 0, it means further investigation is necessary. So you say further investigation needed. So for the points 1 over 2, 1 over 3. So you put all of this into this equation. 6, wherever you see x, you put 1 over 2. Wherever you see y, you put. So I'm not with my calculator here, but you know the answer. So a becomes let me see, solve that. A becomes minus 1 over 9, b becomes minus 1 over 12, and c becomes minus 1 over 8. So use your calculator to solve that. So when you say AC minus B squared will now be equal to minus 1 over 9 times minus 1 over 8 minus 1 over 2 squared. Okay, if you solve this, you would get 1 over 44, which is greater than 0. So AC minus B squared is greater than 0. What is A? Minus 9. And A is less than 0. So this point is a maximum point. Therefore, point 1 over 2, 1 over 3 is a maximum point. So you can decide to find the maximum value by putting this into the original equation. So I guess you understand everything clearly. So solve more examples. You can play with trigonometric functions to check your textbook and all of that. So just do this assignment. Find the extreme value of the function x3 plus y cubed minus 3xy. So that's your assignment. I remain Steve Oshiokhai. Thank you. So I would see if you can still solve more examples before moving to the next part of the course, which is unconstrained optimization. Have a nice day.